Welcome to this instructional video to try to clarify some things that we talked about on Friday. I feel like we need to kind of take a step back and do this a little more in depth so I think we can understand this a little bit better. So on page 22 of the notes we had two situations. We had A and we had B. And then when you do a Diels-Alder on A, you got what we called a cis-meso. And it was very important to show the stereochemistry, and it was insufficient just to draw the lines, just the straight lines of the bonds. Then we did B, and then again the answer here was cis-meso, where you had to show these two methyl groups here cis. And of course, there would be no stereochemistry around these two carbons because that's a double bond. We said this was insufficient because you just drew line bonds to these two methyl groups, not showing me or anyone else that they are cis. But I think I want to revisit A just to give you a little more detail, because I think it's going to be important when you start working some of these problems that you can be able to do this a little more in depth. So really, here's what's going on in A. Okay, so here is our diene, and then we have our dienophile, and I'm just going to abbreviate this COOCH3. This is just an ester, but it's written shorthand, not to have to draw all the bonds. Now here's the real deal here. When you do the Diels-Alder reaction, okay, and you show the arrows like this, these two ester groups, when you form the six-membered ring, they have to be on the same side, but they could add up or they could add down. Okay, that's what we know to be true. They're on the same side, but they could add up or they could add down. So let's draw both products that reflect that. Okay, so let's draw the first Diels-Alder product, and I'm going to show them both going down. And in class I said that it's okay that if you draw the dash group here, it's understood there's a wedge hydrogen. I think I want to do that on these just to keep it somewhat simplified. Or that's one product. Okay. Another one is this. Where they're both going up. So let me move this over. Just I don't want to get crowded here. Looks like we left a bond. Let's don't do that. Well, let me just erase it then. So we're doing the same reaction. We added the ester groups down, cis down. We got to add them cis up now. Okay, so the question in your mind should always be, oh wow, are these the same or different? Okay, well, one thing you can do, and you're probably not going to like this, but this is maybe important. You can assign RS configuration to the chiral carbons and see what we have here. This will be S, this is going to be R, this one's going to be R, and this one's going to be S. Now, there's going to be a phrase that I'm going to start using in class about Diels-Alder, and basically it says if you start with a chiral reactants and you make chiral products, which is what we've done, you get a racemic mixture. Okay, and so this really is what you see here. We have a kind of a racemic mixture of products. This is S, carbon is S here, this is R there. That's a racemic mixture. This carbon is R, this carbon is S here. That's a racemic mixture. But this is very special because this is meso. So there is a plane of symmetry in these molecules. Ladies and gentlemen, the two products that I have drawn are identical molecules. They are the same. You could draw either one. Now you had to draw the dash and the wedge. If you didn't, it would be insufficient. Okay? You've got to draw the wedge or dash to show the cis nature. So that's why that box says cis, but they're meso, because they're the same product, because there's a plane of symmetry in the molecule. Okay, so let's buzz up here. There's A. They only drew one product. Okay, and then I don't think I emphasized enough that there are really two products that you would draw, and they're the same with this one. Okay, well let's keep going. Let's dig a little deeper. Let's look at B now. B, we're also going to get a meso product, but again, I think it's important for you to draw both products, and then let's show that they're meso and that they're the same product. Now, before we do that, I want to make a little clarification of kind of what we did in class. When we're doing a Diels-Alder reaction and we have substituents on the diene, you really have to make two different products each time. Okay, in class it kind of just worked out to where when we did this, we would make these two go up, and then we would say, oh, well, these two will go down. Okay, and then you would get a product. And to be honest with you, that's one way to do it. But in reality, as I kind of reflect on this, for us to do this the way it has to be done, you also have to draw product number 2. And in product number 2, you have to draw both of these down. And you have then, accordingly, these go up. And so you have to draw two different products. Now, the B and C always stays on the same side, and the A and D always stay on the same side when we do these. Okay? So, but we have to do it both ways. In class, it kind of sounded like, and this is my fault, that always draw B and C up and make A and D down and your life will be great. Well, no, it will not be great. It will not be great. So here we go. Let's go to B and let's see what we get. So here is B, and when I say B, I'm talking about this right here, this reaction here. They've only drawn one product, and that's okay because it's meso, but we need to see both products, and then you need to convince yourself those products are the same. Okay, so we had something like this. All right, and then here is our dienophile. Again, I'm just going to abbreviate the ester group. Okay, well, here we go. I'm not going to, I think you see where the arrows are going here. I don't want to do that. It gets kind of messy. But we really have to draw two products. We have to draw both hydrogens up and both methyls down. Then we have to draw one where both of these hydrogens are down and the methyls are up. Those are going to be two distinct products. Now, if those products have a mirror plane, it may turn out the two products may be identical. Okay? So here we go. here would be the two products that we would get. So let's draw both of the hydrogens going up. Okay, and then let me go ahead and finish the deal here on this. Okay, so there's a product, and this is the product that, you know, brought both of these hydrogens up, both of the methyls went down. Well, okay, that's product one, but there's another way to do it, because we have to draw another product where the two hydrogens here are down and the methyls are up. Okay. Methyl up, hydrogen down. And you know what, I don't know if you have to draw the hydrogens or not. On this one, I am choosing to draw in the hydrogens just to make sure we're on the same page here. Okay. Here we go. This is the difficult part sometimes. Are these two products? These are the two products formed. Are they the same molecule or are they different? Well, from achiral reactants, when you make chiral products from achiral reactants, you get a racemic mixture. So I tell you what, you're going to start loving to do this again. So let's do this. This is S, and this is R, and then this is R, and this is S. So my statement holds true. You get, on this carbon, you get a racemic mixture. One product is S, one product is R. On this product, you get an R, and in this one, you get an S. That's another racemic mixture. But there's something special about this molecule. It has a plane of symmetry. So this is a case of meso. And so that's why they called it cis meso. These two products are the same. You can take one and flip it over. Literally take it and then flip it right over from top to bottom flip. You get the same molecule because there's a plane of symmetry in the molecule. So that's why. And then either one of these is fine. You can draw either one because they're the same. That's why they only drew this one, right? Again, that's not. This is completely insufficient over here on the right, with no stereochemistry shown. And just drawing one of those is sufficient. That is fine. Okay? But here we go. I did another example in class. Okay? Let's call this C. And so here's the notes from the class. I just kind of moved the page down a couple of pages. And the mistake that I made here is drawing just one product. And in fact, you, the class, told me this product is not meso. Uh-oh. That means we better consider the other product. So, to draw this product, I believe, what did we do? Yes, we took the methyl group and the hydrogen here on the diene, and we drew them up. And then we took the other methyl and the hydrogen and drew them down. Okay? That gives us a particular product. That gives us a particular product. But guess what? You can't stop here. you've got to draw the other product. You've got to draw the other product where the hydrogen here and this methyl are down. Okay? So, and the question is going to be, are the two going to be the same or not? That's going to be the question. All right, so let's draw these in. Okay, so let's start at the top carbon. In the product on the right, I drew the H up and the methyl down because that's kind of how we were doing it. But you've got to draw the hydrogen down and the methyl up as well. So however you want to do this. Okay, that's fine. And then we got to come down here. And the product that I drew originally in class, I put this methyl up because that's how we were doing it, and I put this H down. I've got to do just the opposite now. So this needs to be up, and this needs to be down. Okay, here we go. We have to draw, and this was the mistake I made in class. I didn't really get into this enough. And I believe someone in the class actually said, "Oh, well, I drew the methyl and the H with different stereochemistry. Is that okay?" And I think I said, "Yes, that's okay." Well, no, it's not okay. It is okay to draw it, but you have to consider them to be different products. Are they different? Okay? So, in class, someone said, "Well, here's your structure. I just switched the stereochemistry of the CH3 and the H and the H and the CH3, and I didn't really pay much attention to it. I'll just let that go." I said, "That's okay." Well, I don't think it's okay. I'm changing my mind. It's not okay. Okay? Because this is not a meso compound. There is no plane of symmetry. So what you have to do now is look at the two products and ask yourself, are they the same or are they different? Well, since there is no plane of symmetry, these are different compounds. And I'm going to suggest to you that you do the little R and S trick, okay? So if you come over here and you look at this carbon, this is S and this is S. Come over and look at the product on the left and assign stereochemistry to the two stereogenic carbons. The rule that I've said twice now, chiral products made from achiral reactants usually occur in a racemic mixture. What that means is, wait for it, here it is, R. There we go. So, you get two different products here. Okay? And this is called trans. Racemic. And you get two different products. You're going to get a racemic mixture, equal amounts of these two enantiomers. You have an RR, and you have an S, and you have an S. On the test on something like this, if I want you to draw both of them, I will tell you. Perhaps I might say, just draw one of the enantiomers and tell me there's also another enantiomer. So I may not always ask you to draw both of these, but you have to know that there's two different products here. You have to know there's two different products. Okay? All right. Well, then it happened. Jessica asked me to do another problem. And I was happy to do another problem. but I unknowingly opened the portal to hell, because this problem here gets highly complex. And I think while I was working it, I figured out that this is way more complicated than I wanted to get into. So I just drew one product, and we just kind of moved on. But we can't move on. We've got to look at this. Just before you go into fits here, I'm not going to ask you to do one of these. This is a little more complex than I think we need to be able to do. Some of you are still drawing 5 bonds to carbon, so I don't think we're going to be able to do one of these. Okay? So, yes, here's a product. Okay? The issue is this carboxylic acid group here, COOH, it's trans. So now you're going to, and you're going to have 4 chiral centers in the molecule. So even if this is cis or trans, it doesn't matter. In this problem, I'm creating 4 chiral centers. Well, we just saw 2 chiral centers, sometimes it gets a little complex. Okay? So we're creating 4 chiral centers. Ladies and gentlemen, is this a product? Yes. But so are these other 3. And I just want to tell you, I'm not going to ask you one of these. This is complex enough. I don't think we need to go down this road for this one. So here's the deal. And I'm going to send you an email explaining this. The feedback loop I gave you, I think it would be good for us to work those problems in class on Monday. I want to go a little bit further in the notes and work those problems. I'm going to give you, if you've already worked on it, that's great. That's just good practice. But I'm going to give you a different feedback loop on Monday and probably have it be due on Friday. Because there's one of these very complex problems on the feedback loop. And that's where I should have worked the key before I gave you the problems. And that's my fault. And that's why I'm making this video. Okay? Now, again, don't get too concerned or any concern about this last problem. I'm not going to get into this. This is way beyond, I think, what we need to do. But this one is a pretty good one. Okay? This is kind of where we're at here. Being able to know that this would be trans, draw it trans, and there'll be a racemic mixture, and then recognizing that, oh, hey, here is a cis. The methyl groups are always cis on the same side, but the compound is meso. I think we need to be able to do that. But the last one I did is a little out of control, I think. So I'm going to end this video. I hope this provides some clarification on what we need to do with these types of Diels-Alder reactions. On Monday, we're going to talk about asymmetrical Diels-Alder reagents. Work through that, do some examples, and then we're going to work the problems I gave you on the feedback. I'm not going to work that 4th one on number 1 because, again, that's more complex than what we're going to get into. All right, so I hope this was helpful, and I will see you on Monday.